Students, this class will be focusing on SAR of tetracyclines. Already we have known the structure of tetracycline. It is a derivative of octahydronaphthazene or tetrazyne. So what is meant by naphthazene? Fusion of 4 benzene rings that can be called as naphthazene, otherwise tetrazyne. While comparing with naphthazene, it is lacking 4 double bonds. That's why they are called octahydronaphthazene or tetrazyne derivatives. Now it is having that 4 rings. No, these 4 rings are essential for activity. If it is fewer than 4 rings, it would be inactive. Now in first position it is having ketone and third position it is having alcohol. So these two keto-enol groups at 1 and 3, that is important for activity. If there is any change in that, there may be loss of activity. And in second position we have that carboxamide, that is CONH2. No, if that is replaced by means of aldehyde or nitrile means activity would be decreased or abolished. And here that nitrogen of amide, no, that undergoes monoalkylation, activity would be reduced. If it is undergoing aminoalkylation, we are getting more water soluble compound, but that would be hydrolyzed in vivo. Example is Rowley tetracycline. Now come to third and fourth position. Third position we have hydroxy group and fourth position we have dimethyl amino group. So these two groups are they are responsible for forming zwitter ions. What is meant by zwitter ion? That is having both positive charge and negative charge. How it forms zwitter ion? Here it is having hydrogen that combines with nitrogen. So because of that, nitrogen is getting plus charge and oxygen is getting minus charge. So the same ring is having plus and minus charge. That's why this is acting as a zwitter ion. What is the use of zwitter ion? That is essential for distribution within the body. So if these two groups would be removed, the activity would be reduced. Now come to the 4A position. So it is here it is having hydrogen that is connected to the ring by means of alpha configuration, and 12A it is having hydroxy group that is connected to the ring by means of alpha configuration. Both ends it is having alpha orientation. That's why these two rings, A and B ring, that would be cis fused, same configuration. That's why these two are cis fused. If there is any change, if any group is getting other configuration, I mean OH is getting beta configuration, otherwise hydrogen is getting beta configuration, means it is not having any activity. So these two rings, that would be cis fused. Now come to fifth position. If we are introducing hydroxy group in fifth position, that may influence the pharmacokinetic properties, and there is no change in activity. Examples are oxytetracycline and doxycycline. And here in 5A position, it is having hydrogen that is connected to the ring by means of alpha configuration. So if you are getting 5 alpha AP tetracycline, so what is that 5 alpha AP tetracycline? That is having hydrogen by means of beta configuration. If you are getting that, we are getting compound that is highly active in vitro but less active in vivo. Then come to sixth position. So sixth position it is having hydroxy group and methyl group. If the hydroxy group is absent, means we are getting compound that is stable to acids and bases and having long biological half-life. And examples are doxycycline and minocycline. If it is having only methyl, that is C6 monomethyl, only methyl along with the 5-hydroxy group. So 6th position it is having only methyl group and 5th position it is having only hydroxy group, means activity would be increased to 2 to 3 times. Example is doxycycline. And in the case of 7th position, if you are introducing electron withdrawing groups, examples are chloro or amino group, or if you are introducing electron donating groups, example is dimethyl amino group, means activity would be increased. Examples for tetracyclines that is having electron withdrawing groups are chlorotetracycline, demiclocycline, meclocycline. An example for tetracycline having electron donating group is minocycline. So if you are having these groups, activity would be increased. Now come to the 11A position. If we are alkylating the 11A position, we are getting inactive compound. And in the case of 12th position, it is having hydroxy group that is connected to the ring by means of alpha configuration. If the hydroxy group is converted to an ester, we are getting inactive compound. The exception is formyl ester, because that is readily hydrolyzed in aqueous solution. Last point is the shape of tetracycline is very important. If we are changing the shape, the activity would be reduced. That's why Here 5A position it is having one hydrogen, no, if that hydrogen is dehydrogenated, if that would be removed from 5A position, we are getting double bond between 5A and 11A. So, if we are getting the double bond between that, the activity would be reduced. That is all about the SAR of tetracyclines.